When looking at exponents, I want you guys to think 10 to the second power also equals 100. There, with the exponent right there tells me how many zeros. 1, 2. So how many zeros are in A? 1, 2, 3. 10 to the third power. How many zeros are in 10 times 10? 1, 2. 10 to the second power. We also know that 10 times 10 is 100, but it's looking for exponential form. So that's why 10 to the second power, or 10 squared, is the answer. Let's do one more. Over here, how many zeros does 1 million have? 10 to the sixth power, because there are 6 zeros. Just count the zeros. Write the following in standard form, and standard form means those basic numbers. So what I do is I take it step by step. 10 to the third power I know is 1,000, because 1,000 has 3 zeros. 4 times 1,000 is 4,000. For C, 5,300 divided by 10 to the second power. I know 10 to the second power is 100. So 100 divided by 5,300. I know my decimals right after that one spot. 1, 2, 2 to the left, because we're dividing and we're getting smaller to get 53. All right, that one I did pretty quickly. I'll do the next one a little bit slower. How about H? 9.4 divided by 2. Divided by 10 to the second power. 10 to the second power is 100. 9.4. 9.4 divided by 100. We're going to the left. The decimal place is going to the left because we're dividing. It's going 2 spots because it's divided by 100. 100 has 2 zeros. You can also look at that exponent to tell you where that decimal is going, how many spots it's going. 1, 2. 94 thousandths. Complete the patterns. These are probably my most favorite things. What I would do first is find 2 numbers that are together and then see what the difference between those are. I've noticed that it is getting larger. 2 hundredths and 2 tenths. 2 tenths is bigger than 2 hundredths. Remember, you'd rather have 2 dimes than 2 pennies. So the decimal point is moving 1 to the right. So if I were to move this decimal point 1 to the right, I would get 2. If I move it 1 to the right again, I would get 20. 1 to the right again, I would get 200. 1 to the right again, I would get 2,000. What I'm noticing here is that as I move the decimal point 1 place value, I'm adding another 0, but make sure that that decimal is still right after the 1 spot. Alright, I'm going to try to find one that might trip you guys up. These all look pretty similar to A. We'll do C. 8,570. Again, I'm going to look for that group to see what changes there. So we go from 85 7/10 to 8 57 hundredths. The decimal point, where did it go from here to here? The decimal point went in between the 5 and the 7. No. The decimal point was between the 5 and the 7, and now it is between the 8 and the 5. So it has been moving 1 to the left. So if we move this bad boy 1 to the left, it would give me 857 thousandths. I know that this number is going to be smaller than this number. I'm going to move my decimal point 1 to the right to get 857. I'm going to move it 1 to the right again to get 8,570, and 1 to the right again to get 85,700. Alright, after a lesson on exponents, Tina went home and said to her mom, I learned that 10 to the fourth power is the same as 40,000. She made a mistake in her thinking. Using words and numbers, or a place value chart, helped Tina correct her mistake. Alright, so when you don't know what her mistake is, why don't you figure out how you would get the answer? So 10 to the fourth power, what does that equal? I know that the exponent tells me how many zeros there are going to be, so it's going to be 10 to the fourth power is 10,000. But she says it's 40,000. I wonder where she got the 4. The only 4 that I see is in the exponent. So maybe Tina did 4 times 10 to the fourth power, which would also equal 40,000. If this was the problem that she had to solve, yeah, she would have gotten the right answer. But we just wanted to know what 10 to the fourth was, which is 10,000. It says use words, numbers, or a place value chart to help Tina correct her mistake. So how are we going to help Tina is what I want you to think. Just giving her this, to me, that would be super confusing. So we need to either use words, numbers, or a place value chart. And I am going to use a place value chart. Actually, I am going to use numbers first. 10 to the fourth power equals 10 times 10 times 10 times 10. There are 1, 2, 3, 4. 1, 2, 3, 4. There are 4 tens exponents mean 10 times itself 4 times. So 10 times 10 times 10 times 10. There is no 4 actually involved. It's just simply counting the number of tens that we have, which equals 10,000. For number 5, solve 247 divided by 10 to the second power, 247 times 10 to the second power. So what I want you to do first is write 247 times 10 to the second power, which is 247 times 100. 240 times 100 is 24,700. I know that because in 247, my decimal point comes after the 1. There are 2 place values, not zeros, friends, place values. There are 2 place values that have been inserted because you are multiplying by 100 to get 24,700. So that's when I multiply. For the next problem, I will divide. 247 divided by 10 squared, which equals 247 divided by 100, because that exponent tells me the number of zeros I'm going to have. And when I'm dividing, I'm getting smaller. So I start at the 1 spot where my decimal point is always between the 1s and the 10th spot, the 10th spot. And I go 1, 2 to get my answer of 2 and 47 tenths. What's different about the 2 answers? Well, guys, look at it. What's different about this answer and this answer? One's bigger and one is smaller. Use words to explain how the decimal points shift. So this is exactly what I would say, or what I would write down. When you multiply by 10 to the second power, it is just like multiplying by 100. Your product is getting larger. When you divide by 10 to the second power, it's like dividing by 100. Your answer is getting 2 place values smaller. When you multiply, you're getting 2 place values larger. That is why there is such a big difference in the numbers, because of the placement of the decimal point. Based on the answers from the pair of expressions above, solve 247 times 10 to the third power, 247 divided by 10 to the third power. So what I noticed from the first one is that I moved when I multiplied, I moved 2 decimal points right. So when I multiply here, I'm going to be moving 3 decimal points right. So 247, 1, 2, 3, 1, 2, 3. When I divide 247, there's my decimal point, 1, 2, 3, to get my answer. Oops. There was a change of 3 place values smaller when I divided, and 3 place values larger when I multiplied. So you just got to see those patterns when you do your work. But that's homework for today. I hope you guys have a great weekend and utilizing our videos. Here is your hint. For me to know that you watch these videos, I really, really need you to have a credibility, so I know that you watch the video. I want you to put a giant smiley face on the front page of your packet. So a giant smiley face on the front page of your packet, so that when I see him Monday morning, I can know that Zachary watched the videos because on his paper is a giant smiley face. Alright guys, have a great weekend. I hope to see you bright and early Monday morning, and don't forget that picture day is Wednesday. So, I'll see you Monday. Bye.